Okay, looking at lesson 28, we are using absolute values, and then we're also using literally rational functions. Not rational functions, radical functions. There we go. I'm with us. Absolute value, if you remember back to when you learned about absolute value early on in middle school, the absolute value is the positive distance from zero. So the absolute value of a number is always positive. Now we will end up with some negatives here only when we're adding or subtracting outside the absolute value bars. Okay, as a reminder, when you see these bars, that means absolute value. Okay, the absolute value is its distance from zero. So if we look at this first one where the absolute value of x is equal to 6, we want to solve for x just visually. This is the only one I'm going to do this on. Visually, here's 0. The absolute value is 6. That means we can have a distance over here to positive 6. This would be an absolute value of 6. Also to the negative 6, that would have an absolute value of 6 because its distance is 6 units away. This distance is 6 units away. So x is always going to be equal to the positive and the negative form of whatever it equals. So here we'd say positive or negative 6. You can either write it plus or minus 6 here, or what's going to be more helpful as you do these is setting it up x equals negative 6 and 6. That's really going to be the only one where your number's the same because we haven't added or subtracted or done anything else to it. I'm just running through the odds on this because they're pretty simple. Okay, in order to solve these problems when you have more than just an absolute value going on, you're going to take whatever is on the left-hand side and you're going to set it equal to the positive version of the right-hand side and the negative version of the right-hand side, because this absolute value, those bars, are always going to be equal to the positive form and the negative form. So step 1 is to get your absolute value bars isolated on one side, and then you'll solve two separate equations. So if we look here, we've got x minus 8, the absolute value of that equals 3. There's nothing else going on the left side with my absolute value bars. So once we have it set up on its own, we're going to set up two equations. X minus 8 equals positive 3, and x minus 8 equals negative 3. Okay, because it can be the positive or the negative side of our number line. And from there, we're just solving for x. So we add 8, so x is equal to 11. Here we're going to add 8, negative 3 plus 8 is positive 5. So these are my two solutions. Okay, same thing down here on number 5. Sorry, I was trying to see if something else was going on this one. Okay, so we're going to say x minus 4, since we just have our bars by itself, equals negative 3. And x minus 4 is equal to positive 3. We're just going to use the positive and negative form of this number. Okay, so x can be equal to 4 plus negative 3 would be 1, and x can equal 7. Now you should be checking your answers in here just to be sure that you get the same number each time, but I'm going to go ahead and let you know that's correct. I'm going to flip through. I forgot to check one thing before. Oh, yep, okay. So the right idea, same thing like on 6 over here, just to kind of peek through. You're still going to say x plus 2 plus 3 equals 2, and x plus 2 plus 3 equals negative 2, and solve from there. 2 minus 3, sorry. Pretend that's a minus. I have no brain left, you guys, so we're just going to hope for the best in this one. Okay, those are minuses. You solve through. Both times you get x minus 1, x minus 1. There it's equal to positive 2 and negative 2. So x is equal to 3 or negative 1. Okay. You will encounter a couple once you get into the later pages that you've got like x squareds or things inside your absolute value bars. You're still going to set it up the same general way. The one thing that will come up, I think it comes up on D, is, yeah, it's D. You've got 3 plus, so I'm just showing you, I can do this in a different color. Let's pretend like this isn't here. So on 28D, you've got a problem that looks like this. 3 plus the absolute value of x minus 2 equals 4. Before you can set it equal to the positive and the negative version, you have to isolate the absolute value bar. So you'd subtract the 3 first. So you get x minus 2, absolute value, equals 1. Then you'll say x minus 2 equals 1, x minus 2 equals negative 1, and solve from there. Okay, so if you have something on the same side as your absolute value bars, you just need to move it to the other side. So that way it's just your absolute value bars when you set it equal to the positive and the negative form. Okay, coming down here, it says solve for x by raising both sides of the equation to the same power. Check your solutions. Okay, so since this is the square root of x, to get x, we're going to go ahead and square both sides. The square will undo the square root. That leaves us with x equals 9. If you plug it back in, the square root of 9 is 3. Yay! Okay, if we got a cube root, we're going to cube each side. So x would equal 2 cubed, which is 2 times 2 times 2, which is 8. And again, the cube root of 2 is 8. Okay, they get a little bit more advanced when we come over here, but honestly, they're really not too bad. So on 9, we're square rooting. So the opposite of square rooting is to square. As long as we do the same thing to both sides, everybody's happy. X plus, the square root of x plus 3 squared is just x plus 3. That equals 16. So x is equal to 13. Just kidding. Okay, 11. You've got to isolate your radical. So we're going to subtract 7 first. We've got the square root of x minus 2 equals 4. And now we can square both sides. So x minus 2 is equal to 16. Then x is equal to 18. Okay, again, you should plug this in to check. So if we think about it, 18 minus 2 is 16. The square root of 16 is 4. 4 plus 7 is 11. So it all works out. Yippee, skippy. Okay, looking at 14. Now we've got a fourth root. Exciting. First thing, you have to isolate your radical. So the radical is the rooty looking thing. It's just a fancy word for rooty thing. Surely it has a better definition, but let's just go with it. Add 1, add 1, add 1. Fourth root, we've got 2x plus 8, fourth root, equals 2. We're going to raise, let's go purple. We're going to raise both sides to the 4th power. So that leaves us with 2x plus 8 equals 2 to the 4th power, which is 16, because 2 times 2 is 4, times 2 is 8, times 2 is 16. Biggest thing on these is to make sure you're raising it to a power, not just multiplying. So then 2x equals 8, and x is equal to 4. If we check ourselves, 2 times 4 is 8, plus 8 is 16. The 4th root of 16 is 2. 2 minus 1 is 1. It checks out. Okay, 15 is where the fun comes in. Okay, we've got 2 different radicals going on here. So we are, sadly, because we also have a minus 4, this is going to get a little messy along the way. What we're going to do is we're going to move this negative 4 to the other side, because we're going to be squaring things, and it's going to be a lot easier to square just that square root of x minus 4 instead of the 2x minus 4, because this is already a binomial. This is a monomial. We're going to move this over here so it's not nearly as ugly when we work it. Okay, so we've got the square root of 2x minus 4 equals negative square root of x plus 4, because we add it to the other side. To get rid of our square roots, we're going to need to square both sides. Okay, so we're going to square both sides. On the left-hand side, that'll give me 2x minus 4, which is so nice and happy. On the right-hand side, we're now squaring this binomial. I'm going to come out here to the side and write it out because it gets a little bit ugly. So we've got negative square root of x plus 4 times negative square root of x plus 4. Okay, so this is just our foiling. Negative root x times negative root x. Negative times negative is a positive. Square root of x times square root of x is just plain x. Okay, so then we've got negative square root of x times 4, which would be negative 4 root x, plus 4 times negative root x. So we've got minus 4 root x minus 4 root x, which would be minus 8 square root of x. Okay, and then we've got 4 times 4, which would be plus 16. Okay, so now we've got x terms, constant term. We still have the square root of x. We're actually going to end up squaring again, but we want to combine all the like terms we can first before we get going. So if I subtract x from both sides, minus x, then I'm going to subtract the 16. I'm going to leave my square root on the right-hand side. When we simplify this, we're going to have x minus 20 equals negative 8 square root of x. Now we have a square root again. That negative is there. We do not want to divide by the 8 because that would make my x divided by 8 and my 20 divided by 8, both which would make very ugly numbers. So we're going to go ahead and square it with the 8 in there because it'll just be a bigger number. So now we're going to come in and we're going to square both sides. Lucky for us, we have another binomial squared. So x minus 20 squared is going to be x squared minus 20x, which would be minus 40x. Negative 20 times negative 20 is plus 400. Negative 8 square root of x squared. So negative 8 squared would be 64. Ooh, that was ugly, but you get the idea. Root x squared would just be x. We've got 64x. Whenever we have a squared term and a linear term, we have to solve by factoring. So first we have to set it equal to 0. So subtract 64x from both sides. 64x minus 64x. We've got x squared minus 104x plus 400 equals 0. Now we get to do our favorite thing and factor. Multiplies to be 400, but adds to be negative 104. Lucky for us, it's pretty easy. 100 times 4. Negative 100 times negative 4. They add together to be negative 104. Multiply to be positive 400. So my solutions here would be x equals 100 and x equals 4. But because we're such good math students and we always check our answers, we need to check both of these things out. So I'm going to make a little box over here for checking. If we plug in 4, I'm going to start there because it's smaller. We've got the square root of 2x minus 4. I'm just going to rewrite it up here. Minus 4 equals negative square root of x. If we plug in 4, we get 2 times 4 is 8, minus 4 is 4. We get the square root of 4, which is 2, minus 4 would be negative 2. Over here we've got negative, the square root of 4 is what we're plugging in. So the square root of 4 is 2. That negative is outside the square root, so it just makes whatever's inside the square root negative. So negative 2. That one checks out. This one we can box in. Everybody's happy. Now if we go in, and you can guess what's going to happen, and plug in 100. So that gives us the square root of 200 minus 4 equals negative square root of 100. 200 minus 4 is 196. The square root of 196 is 14. Minus 4 gives me 10. The square root of 100 is 10, but we put that negative out front. That gives us negative 10. Negative 10 is not equal to positive 10, so this is not a valid solution, and 4 is our only answer. Okay, so that's it's really just basic algebra. As you go through and do this, square both sides if it's square roots, cube both sides if it's cube roots, fourth power both sides if it's fourth roots. Sometimes you're going to have to factor it. Usually that's just the last question where you have to factor. On these first problems, just make sure you get your square root bars by themselves before you do things. So like we did on this one, we had to do it. But that only is in 28C that happens. When you have the inside your absolute value bars. I'll do one more extra example up here. So this is like 28C. 28C has some like this. Let's try 4 says x squared plus 1 equals 7. You're going to solve it the same way. X squared plus 1 equals 7. X squared plus 1 equals negative 7. X squared equals 6. So then x is equal to, whenever you take the square root of a number, you get a positive and negative form of that answer. So you'd have plus or minus the square root of 6, because the square root of 6 squared is 6, and the square root of negative square root of 6 squared is also positive 6. That was a tongue twister. Okay, so then here we get x squared equals negative 8. Well, when you take the square root of a negative number, you actually get an I. So how this works, you should have encountered this because they're throwing it in here. You should have encountered this in Algebra 2. The easiest way to kind of think about it is, so here we're going to take the square root. So the square root of x squared is x. So we've got the square root of negative 8. This is equal to I square root of 8. Okay, I don't know what it's doing. Okay, the square root of negative 1 is I, which is an imaginary number. So we're just going to pull the I out. Whenever you have a negative inside your square root, really all you need to do is take that negative out of the square root and turn it into an I. So it just leaves and becomes an I right here, a cute little cursive I. Now we should simplify the square root of 8 just so that way it's more broken down, just like we reduce fractions. 8 is 4 times 2, 2 times 2. So this would be 2 root 2. The square root of 8 can reduce down to 2 square root of 2. So this is going to be 2i square root of 2 is how it simplifies down. Anything that's a pair leaves the radical and comes out to the front, and then your leftovers are left inside. I'm going on Algebra 2 assumptions here. So hopefully you've seen some of this before. If not, then let me know and I can do another extra bonus on how to simplify imaginary numbers. So hopefully that helps. Good luck. Let me know if you